thank you for joining today's webinar. So my name is Sibel Dasti. I am a manager within the international recruitment team in Uni, which is a sister company of Global University System. And today we are very excited to talk about one of our premium university, Canterbury Christ Church University, located in beautiful Kent. So we will be discussing engineering. And for that, I'm very happy to introduce you Dr. Adil Imam, who is the course director for engineering, and Mr. Richard Vanner, who is our international student manager at Canterbury. So before we start, though, some quick housekeeping rules. You are all in mute. For any question, please use the Q&A box rather than the chat box, and we will be happy to answer all your questions at the end of the presentation. So the floor is yours, Dr. Adil.
Hello, everyone. Hope everyone can hear me, and everyone's having a good day so far. In the next hour or so, I don't think I will be taking the whole hour, but it's just going to be me talking about the School of Engineering, Technology, Design at Canterbury Christ Church University. So just give a little bit of introduction of myself. My name is Adil. I'm the course director for General Engineering, and I'm also the marketing lead and admissions lead for the school. I know, Sybil talked about where we are located in beautiful Kent. So just to give you a little bit of an overview of where we are located, we're in Canterbury, but CCCU as a whole has multiple campuses in Medway, Discovery Park, and Solomon's Institute, but the engineering campus is based in Canterbury, and we'll get through to the building and the facilities in a few separate slides. Location-wise, it is very, very close to London. Just in about 45 minutes drive to the M25, and then you can cross into London. Good facilities to connect into London as well. There's a fast train which puts us into the center of London in about 55 minutes or 50 minutes sometimes. So easy commute into London, but we've got slow trains as well. Ideally, you can live on campus, or there's a lot of accommodations around the campus, but very easy to get to London. And if you catch a bus in about 20 minutes, you will be in Dover, which is the closest point to mainland Europe, and you can see ferries, and in an hour you could be in France. So good connectivity to London and to Europe. If you want to fly out home or something, Gatwick Airport is again about an hour's drive from the university as well. So good location. I know it's close to the suburb of London, but it's also tucked away into Kent, which is known as the Garden of England. Quite picturesque town, very historic town. Got buildings about 1,000 years old and a lot of history here. So even if you're studying science or any STEM subject, you get to learn a little bit of history anyway, just being at Canterbury. So that's the location. I'll give you a little bit of overview of our school. We're working with industry. We are working, the courses have been designed in a certain way that it helps transform student lives, not just learning engineering, but preparing them for industry. We are working with the industry in the local region and even internationally to try and build different aspects of it into our courses. And we'll try to give you a little bit of an insight in the next 30-35 minutes about what we do. If you have any questions, please feel free to type it up in the chat. If I'm saying something and you have a comment on it, I'd like it to be interactive. I don't know how interactive it would get, but feel free to ask questions, and I will try my best to answer. If not, I will guide you to the best person who could answer those things. So our industry, or our university, is based on innovation. We've got a new Kenton Medway Medical School, and that feeds into a little bit of the biomedical engineering that we're doing and working with the local hospitals and the health services in and around Canterbury and in the Kent region. There's a lot of investment happening, especially in engineering and STEM subjects in the area. We've got Discovery Park, as you saw earlier on the map, and that was again focusing on the different the industries that are there. Pfizer is sitting there. There's a lot more companies that we tend to work with and building relationships. So comparatively, we are a new school, but we have got relationships which we're building upon, and it is growing exponentially right now. Okay, so there was a recent transformation on the campus as well, and so we'll talk about engineering and computing at Canterbury Christ Church University. So we've got recently funding of about that jumped faster than I wanted to. Sorry. So we've got funding to build a new STEM building, which was completed during COVID and has been in use for the last 3 years now. It is named after Verena Holmes, who was the first women member of the IMechE. And if people are interested, there is an IMechE webinar where they are revealing her portrait in the IMechE birdcage walk building next week or the week after. I think it's the first week in March. You can sign up to that, and they're celebrating women in engineering. They've recently named one of the high-speed trains that runs between London and Canterbury and beyond after Verena Holmes, because a lot of the engineering work on the train coupling was patented by her. So we have created this new building, and that's where all the engineering and computing classes are being held. So just to give you a preview, that's the Verena Holmes building, and it was inaugurated last year by Princess Sophie. So we had royalty on ground as well, and it's split up into 4 floors. We've got sports science on the ground level. We've got engineering and computing on the first level. We've got psychology and health, 3rd floor, and we've got life sciences on top. So, but there is cross collaboration between researchers in computing and engineering, working with all different courses and industries across the building. So hopefully I get to see you, or I hope all of you, or at least some of you, on campus in the near future, and then we can have a tour and see what opportunities are there. Okay. Now to get into the slight technical side of things, the world and UK needs engineers and computer science experts. The world is changing. It's becoming more digital, and innovation is driving it so fast. It's changing every day. We've got a lot of engineers in industry, but if you look at it as a percentage wise, it's only 19% of the UK workforce. So there is a demand, and the demand is increasing in the near future. So because one of the biggest problem or estimated issue is a lot of the engineering workforce will retire by 2026, leading to a huge demand of engineering requirements in the UK and across the world as well. So there is a shortfall of engineering graduates every year, and companies in the UK are struggling to meet their engineering numbers and their requirements. So it is something that would look forward to as educators to try and fill the gap between the requirements and the engineering graduates. So if you're thinking about a degree, I would start thinking, okay, what next? Where do I work? What do I want to do? And start thinking about the next step. And UK provides that opportunity right now with a lot of openings up in there. So right now, the annual shortfall is estimated to be about 20,000 every year, but there is estimates of about 1 million engineers by 2030, which would be in about 6 years' time. So it is causing a little bit of scare, but then if you are picking engineering and computing, then with very good work, there is a job waiting for you at the end of that university degree. So I hope the slides would be shared. Well, it'd be recorded and sent across anyway. But some of the stats put up by the IMechE, the Royal Academy of Engineering, the big engineering bodies in the UK have all estimated that we need skilled recruits, and the whole point is you do this degree, you do engineering or computing, and you would apply it, and the biggest thing is to get a job at the end of it and be in industry and contributing to the innovation that we've been discussing. Okay, so that's the UK requirement and demand, which and the estimates. And now I'll try to tell you about what we do at CCCU. So we've got a very new building that we talked about, but again, the labs as well have been quite built to specification. We have got some machinery which I will show in the few slides and showcasing the teaching and the facilities that we've got. But we've got a whole floor and maker space dedicated to it. Hopefully, someday you come across and have a look at them and use them. But there are videos and stuff on the university website that you can have a look at and get a virtual feel of what the university would feel like. Across the school, we've tried to implement the CDIO framework, and we'll talk about that in a few slides. And overall, our two main focus is teaching and widening participation. So making sure people from different backgrounds, even if you haven't done science or STEM at A levels or your higher education, if you've done English and math at your GCSEs, which would be the 10th or in India. If you do that, then we have foundation courses that you can use to get into the university, and we can build you up for the the engineering courses and feed that into your growth. But widening participation, so people from all walks of life are welcome to take up engineering and computing. It is something that we realize is, there's drawbacks for everyone, depending on where you're from, based on your education, but we have created pathways which help include people from all walks of life to take up engineering and computing and be a part of our courses and progress from there on. Okay. Why are we trying to do that? Because diversity in technology and engineering is something that is really, really quite it's not there yet. We are trying to improve it and make it more inclusive. A lot of engineering historically has been male dominated, which does result in a lot of things that are not being engineered in a right way. So we're trying to make it more equal, more diverse, more inclusive. It does help in, stats has shown it does help a company improve its profit. It has provided improved health and safety, and it does give, different perspectives which people might not have been looking at. So some examples would be, a lot of there is this misconception about women not being great drivers, but that does stem due to the fact that the cars have been designed by men, and it's not very well designed for women, and the physiological parameters of the women's eyes, it does not cater to everyone's needs, and all of that leads to a discrepancy in the stats. So one of the nicest things about this picture here is a lot of the testing for car safety or any equipment safety is done using a dummy. They use a 50 percentile dummy, so that would account for 50% of the population, but the female dummy does not account for more than half the population. So it's fifth percentile, so probably 95 percentile of the population is not being covered. And again, there's so many different technological and engineering challenges out there in industry that based on different genders, different racial parameters, that it still exists and we need to try and change. We are trying to work with a company in the UK, it's a startup that started in Australia, that are designing women's rugby shoes, because any football and rugby shoes for women have been taken from the male-based industry and reduced to meet the size standard, but it doesn't take into account the biomechanics or the physiology of the women foot. So there are a lot of challenges in technology and in engineering that needs to be focused on, making the world better, but better for everyone and making it more inclusive. Okay, 51% of the society is female. A lot of the work done so far does not take them into consideration. So it's trying to be more ethical and make it more inclusive for everyone, irrespective of their background. So that's the whole ideology behind our courses and reasoning why the courses are set up the way they are. So based on that, I would like to talk about what our teaching is based on. Does anyone know what CDIO means? I know there's a chat section if people want to drop in. I might leave a couple of seconds if people want to take a guess at what CDIO stands for. Or, I don't know. Okay, so I'm not getting any replies. So if okay, give me 1 second. Okay, so CDIO stands for create, conceive, design, implement, and operate. It's a methodology used by, designed by MIT in the US, where they look at a problem and it's looking at creating a solution, designing it, implementing it, and operating it. So a lot of our teaching is based on the CDIO framework, and there are different examples that we tend to use. We have written assessment briefs in a certain way that every assessment that we do or every module that we teach have an element of CDIO. And I just wanted to talk to you about examples rather than just trying to tell you what we do. One of the examples that we did a couple of years ago was these are first year students. We were working with a company which was a subsidiary to Ford, and they would build slam locks. So slam locks are locks that when, if you've got vans or large doors and you could shut them and the door would lock behind it, and they were looking at how could we develop these. And well, usually when we run a CDIO project, it's what we try to do is get them from industry. And now that may be a local industry or an industry beyond borders. Right now we're working with a company in America to try and help them design better rackets. But, so the idea is to get real world problems and help students solve it. But sometimes, like in this case, what would happen is the students would do a design that the company really, really love, and they want to buy the rights to it, and they end up using the product in industry. And these students now that you see are in our final year. So this is from 2 years ago. They were first year students, and they designed something that the company really liked, and they paid them £3,000 as a prize to take their design and put it in industry. So the whole idea of courses that we teach at the School of Engineering Technology Design, so all our computing courses and engineering courses have these projects built into them, so that as you're learning, you're building your CV, you're building parts of it that you can show that you've worked with industry-based problems, and you're not just working on hypothetical scenarios. So what you're doing is affecting the industry. Sometimes, your designs may win money. Sometimes the design gets picked up for more research work that leads to work after your final year, or internships. So you can work with the company during term time or in between your term and become a part-time employee. There are different options, but it's all about trying to build different relationships, between students and the industry, so that the students also get to understand what the industry is like, and they get to build their CV and their skill set along the way. And, hopefully they feel a little bit more industry ready at the end of the course. So this was one of the CDIO examples. Another one is the for one of our CAD modules, we had reached out to a local industry. We have an industrial liaison officer who goes around looking at different projects. And this was a collaboration between Cactus Graphic and our second year CAD module. So Cactus Graphics is a company that does a lot of printing, different boards, paper-based, and any kind of printing. Then they are one sub solution. They were sitting in a warehouse which was quite old, and we're moving into a new purpose-built warehouse, and they wanted to look at the layout of how the machines would sit. So we did go to their old warehouse one morning and spent a whole day taking measurements of the different machines. And the students worked in groups looking at, so they recreated these machines, looked at the manufacturing layout and how the machines would sit. Certain areas of the machinery needed to be, temperature and humidity controlled, and how would they end up doing that? Find out the best layout to improve efficiency, so that the materials don't have to move a lot. And we've got that company has now moved into the new location, and and I had a chat with one of our colleagues yesterday that we needed some printing, and we were going, they were the ones who were helping us out. So it's been 2 years now since we did this project, but this company is still in our contacts, and if they need support, the students are there So, these are real life examples that you can add to your engineering portfolio if you're a student with us, and it helps showcase impact of what you're doing on the industry. Okay, so that's another that was the CAD example. I think I've got one more. Yeah, so we are on the biomedical side of things, we did work with a company called Xroid, which does electrotherapy for hemorrhoid treatments, and they were looking at creating a device that would improve the hygiene factors of using a device that is not very, reusable friendly. So trying to ensure that it's very hygienic, meets all the health standards. But they were getting issues about people trying to reuse, which would lead to infections and cross-contaminations. So the students were asked to work on designs, and this is one study where it was, it was shown that not one design came out as best, but there were ideas from different groups that the company then tried to incorporate. And it took one of our biomedical engineering students, following their completion of their degree as a full-time employee, to try and look at how do we improve this device. And based on the ideas they got from students, they're still redesigning it and improving it. But that student did work with them for 6 months and then has gone to a better job opportunity when it presented themselves. So a lot of these projects, even though it's quite simple, straightforward, it might look like a simple university assessment, but it has always led to more collaboration with the industry, a better job opportunity for the students, and an eye into the industry and how the industry runs. So, we've got more examples if, at the end of the webinar, if we have time, we can sit and try to discuss more of them. But, the whole idea of the CDIO project that we run at our university is to try and create real life opportunities for students, which does support them. And in all honesty, a lot of these ideas, as academics, we might not know the right solution. We are guiding the students on how we would approach this problem, and we let the students try and learn along with that guidance. So, sometimes even we are amazed by the quality of work a student might put out if we remove the barriers of thinking and, let them just design on themselves. So it's a learning curve for the students and the faculty. There is no single way of saying this is the best, but there's always ways of improving a certain thing. So it is quite fun to go along that journey with students on improving a product or redesigning something. Okay. Oh, sorry. Just wanted to show a few of the things. Hopefully, if you're in the UK, it's a lot easier to come down to an open day or an answers day. But since we're trying to do this online, I just want to show you some of the equipment that we have and we use for our research and teaching. So a lot of our projects are based on CDIO, so we work with industry to try and get those ideas in, but it also stems from our research. So, whatever our faculty is researching on, a lot of the times we put out opportunities for students to work on that research and, improve your research skills, get to work on that paper and be a part of it. And a lot of it is based about a manufacturing capability. So we have a lot of expertise of additive manufacturing. So we've got 3D printing. So we've got our usual Ultimaker FDM prints. We've got the resin printer in Formlab. We've got the fiber composite, which can print out carbon fiber and Kevlar in relation with nylon, so we can have a composite material 3D printed. And we've also got a high-tech DMG Mori metal printer. So we're looking at laser sintering, so 3D printing using metallic equipment, and we're working with a few companies who are making very lightweight titanium parts. So one of them is a company called Craft Bikes, and we had final year students last year working on their design and improving the way the structure of the whole bicycle itself. And it's a titanium bike, but it weighs absolutely nothing. So it's quite intriguing when you have that metal processing power and do redesigning of products and reducing mass of them. So a lot of our research is on additive manufacturing, and you get to use them along with your teaching facilities and during term times. I know someone's got their hand up. If you wanted to type a question, more than happy to try and answer that right now, or I think the plan is to keep the questions till the end. But if you put something in the question and answer, and if I can answer quickly, then I'll try to do that as we go along. But yeah, so we've got additive manufacturing, which is one of our main focus, and we've got a few students and members of staff who are doing research on different things. So I had one student last year looking at 3D printing roller bearings to try and see if they are, quicker in cases of in places where you might have a long lead time to order a roller bearings and getting that to delivery. So additive manufacturing remains one. Then we've got laser cutting, and laser processing. So we work with plastic, acrylic, wood, metal laser cutting, and engraving. So we've got academics who are researching into the laser technology and that interaction with manufacturing techniques and how it reacts with metal. So I know we've put a picture of a thin metal sheet being cut, but then it can cut up to 20 mil thick steel bars as well. So it does change time, but it's something that the students are working on, getting to understand how that changes the edge and the material and the surface finish, and understand not just the process, but its effects and capabilities, advantages, disadvantages, looking at the whole picture of it. We've got more research facilities. Sorry, if I can get. Yeah, we've got research facilities looking at CNC machining. So a traditional workshop, lathe, milling, turning, drilling, all of that. And then we've got the CNC versions of them so the students understand that what a traditional machine looks like and what a computer controlled machine looks like, what is the differentiation, and how has that innovation changed a few things, what are the limitations. So they get to work hands-on with all of this. Once you get we had a few students start in COVID, but now that all the facilities are open and it's on campus learning, you get to train yourselves on these machines. They're open workshops where you can come in, work on a project that you're maybe looking at, or if you train yourself on certain machining aspects, then just need to book in time with the technician, clear the health and safety risks, and get to work with these machines, train yourselves, learn how to use, and carry out the projects that you're trying to do. When you get to final year, during your final dissertation time, there will be afternoons booked out just for you so that you can come in, use the machines whenever you want, and build your prototypes, your designs, and bring them to fruition, essentially. Okay. We also got a material testing section where You can carry out rigorous tests, Rockwell hardness. We've got universal testing machine, which you can pull apart materials, squeeze them, and we've got the SEMs to try and understand the microstructure of them based on based on any process that you've carried out or anything that you've printed, and you've tried to look at the microstructure of it or the finish of it and try and understand how would you try and improve those things. So all of these facilities you see are used for teaching and research, and students have access to all of them. You can get trained on them, build up your skill, and add it to your CV that you're okay with material testing or working with different machineries and understanding how would you analyze certain aspects of materials and how would you apply it to engineering. Okay. We've got another lab which is based on a chemical engineering section, and we've got fluid trainers that look at how fluid flow. Now, I know some of you might be interested in computing, some of you might be interested in mechanical, some of you might be interested in biomedical, but we also do general engineering, and a lot of engineering aspects that I feel are skills that you learn that you can apply to any industry, right? So my research is sports engineering. Now, when you look at fluid trainers or, we've got wind tunnels to look at airflow, we all try to think, okay, wind tunnels means aerospace engineering. But, if you know how to use a wind tunnel, then you can try and figure out, okay, you understand how you can analyze fluid flow across an object. Now, if you put a plane in your study and you try and understand how the structure of a plane is affected by wind, that could be aerospace engineering. If you put a car in there and try to understand the aerodynamic effects of how you're driving, or the shape of the car would be affected by wind or air or drag, that's automobile engineering. If you put a Formula car in there to try and figure out, the downforce it would generate, that could be motorsport engineering. Now, if you put a football to try and understand how it would fly through the air or how a golf ball goes through the air, that's sports engineering. But all of that is still, you're looking at the basic underlying physics of fluid dynamics, but your applications are beyond just what you think you're studying. Now, same goes with any other test. If you learn how to do a material test, that doesn't mean you're just a material expert in one industry. You can see how that applies to different places. So even if you're looking, let's say materials used for planes, that could be aerospace, but that material could be used in other applications, and it does affect from industry to industry. So a simple thing I would try and explain is, if you use foams which are super lightweight and are providing the right material properties, it was used in the aerospace industry, but then Adidas tried to use it from there and put it in their running shoes to try and build the Vaporflies, which are helping them break marathon records. So research or all the engineering skills that you learn are applicable across industry. So it is quite important that we understand that, yes, we learn a few things, or our degrees might say biomedical engineering or general engineering or mechanical, but you get skills that you can apply to any industry that you could walk into. So I would always say engineering is problem solving, and it's up to you where you want to apply those problem solving skills to. So there are a lot of options that you can go through. I will get to the side of things that what courses do we offer, but I just wanted to show before we go there, we have got comparatively, we are quite young, getting through the first few cohorts of engineering, but we've got great, amazing success stories. And if you look at just from the first batch of engineering graduates, they've been working in industries above and beyond what we expected. And we've got them working at Network Rail. That student also had an offer from the National Grid. We've got a couple of students working at BAE Systems, looking at data intelligence, looking at systems engineering. We've got product design engineers who've gone on to work with Pentelec, which is a construction-based company. And well, they graduated in September. They started there in September, and within a few months, they've announced that company is now funding their masters. So they're going on to do a masters based, a masters program that is fully funded by the company, and they will come out and continue their growth in that company. We've got biomedical engineers who've gone on to work for NHS. One of them is a clinical researcher, and NHS has put them through a master's course at UCL. So they're doing the master's course and they will join the NHS as a clinical researcher. We've got biomedical students working with prosthetics-based companies and other biomedical firms, and they're nice enough to come back and give a chat to or have a chat with the students to try and tell them their journey and where they are. So one of our general engineering students from last year, yes, he graduated September 2023, and he's been working with a company called Strabag, which is focusing on the tunnel building for HS2, which is the high-speed train. And coming from, he was interested in civil and wanted to go down that way. So there are options, and there are a lot of jobs in and around the university, in and around UK, that you can get your hands on as soon as you finish your degree. We can all try and say, yes, you want to do a degree, but the whole point is, what do you do with that degree, and start looking forward to next. So throughout the 3 years or 4 years, if you're doing a foundation year with us, we try and build your skills, not just the technical side, but also your people speaking skill, your communication, different skills which will make you a better engineer in the long run. So from our engineering side, we've got all of these companies. From a computing side, they've also gone on to work with different computer solutions. I know maybe the slide's not up to date. There are a lot more companies that our students have gone to, and I spoke to one of them a couple of days ago who's going to Collins Aerospace as well. So you have amazing opportunities to change the world, and you can come do a degree, but our focus will always be what beyond that degree. Study, yes, your focus is to learn, but also try to look at the skills that would help you get a job beyond industry. So we've got more students who have gone on to do other things. They've gone on to higher education and doing a master's or a PhD program in different universities and locations all over the UK, and are enjoying what they're trying to do. And at the end of the day, that's what I think should be the end goal. So you do something that you enjoy, and you earn a living out of it as well and have a better life. Okay. So now on to the technical, on the offers that we have as a university. Just wanted to show what all do we offer as a school of ETT. Oh, sorry, there's a little bit of things that I missed. Was we're doing MScs and PhDs across the different areas in the UK. They've gone on to other universities where they're doing research as well. So it doesn't just have to be industry. You can get into academia, do good quality research as well. Okay, so just to give our undergraduate, so these are our undergraduate offerings from the computing side. got software engineering, computer science, computer forensics and security, data computing intelligence, and business information systems. On the engineering side, we've got biomedical, chemical, drug design, mechanical. We've got a couple of pathways. You can do just mechanical, you can do advanced manufacturing, or building services as well. And we do general engineering, which is a bit more broader. If you have questions about all of them, feel free to ask. If I'm not able to answer that, then me or Richard will guide you to the course director, who would be able to answer those questions for you. If it's related to general engineering or mechanical, then yeah, I will try to answer everything I can. Our chemical engineering course has been accredited for the next 3 years, and our other mechanical and related courses are undergoing the accreditation route right now, because our first cohort finished last year, so it was undergoing that process correctly. That's our undergraduate offerings. We do offer foundation year as well. So if you come from a background where you haven't done science or math at an A-level equivalent, we can still get you into a foundation year where you can, build up those science and math skills, physics or math skills essentially, so that you can get into engineering and then still become a good computing engineer or just an engineer in general. Okay. On the postgraduate side, we offer 5 courses so far. We've got manufacturing, advanced manufacturing systems, and then advanced manufacturing with robotics. We've got cybersecurity, we've got data intelligence and Internet of Engineering, Internet of Things. So, looking at how the digital world or the real world nowadays is using a lot of data and sensors, and improving systems using data and Internet of Things. So those are our UG and PG offerings. If you'd like to see what our university does, or some behind the scenes and some more information, that's the QR code for our Instagram. You can follow us there, have a look. I always tell anyone who is trying to, or who is considering us as an option, have a look at all the things, the course, the social side, the city, because you're coming here, you do get to learn the technical skills, but you also, you're spending a lot of time with the people in and around. The beautiful, beautiful town to study, and if you want anything, London's not too far away, less than an hour. And yeah, I think I've talked for long enough. I've left some slides, some contact details on this slide. If anyone wants to have a chat or has any questions about any of the courses, there are people in the chat, or there are people who've organized this, or if you want to get in touch with me, then you're more than welcome to, and I can guide you to the right people. Right. So I've talked on for way too long, and I think if people are still awake.
That was very insightful, Dr. Adil. Thank you very much. Before we get to the Q&A, I think Richard has a part regarding the English courses.
No.
Richard?
Yeah, thanks, Sibyl. I was just going to mention our pre-sessional English courses that we offer. We offer our pre-sessional courses in the summer before entry onto your program, and we have a 6-week and a 10-week pre-sessional English course. We also offer our pre-sessional courses online as well, but if you decided to come to Canterbury to take the pre-sessional course in person, that would be with a single visa. So you would do your pre-sessional course, either a 6-week or a 10-week course, which would then lead into your chosen program of study. Thank you very much. Thank you very much, Sybil. I think I can see we've got the slide here. Are you able to move to the next slide, Sybil? Perfect. Thank you very much. Here are the dates for the pre-sessional English courses. So a 10-week and a 6-week. Next slide, please. And here are the entry requirements in terms of English language. For the 10-week pre-sessional, we'd require a 5.0 in IELTS overall. And for the 6-week pre-sessional, we'd require a 5.5 IELTS overall. More information about our English language entry requirements, including some of the other English tests that we accept, can be found on our website. Thank you very much, Sybil.
Sorry, I'm getting unmuted. Here we go. I am back online. Yes. So we have some questions that came in, and I would like to start by the first one. I will be glad if you will talk about the postgraduate certificate in education. Is it something that we are offering?
Yes, we do offer that, but that's a different school. That's not the School of Engineering, Technology and Design.
This is this is for next week, actually, Sybil. Our webinar next week will cover some of our education courses. So I think this applicant should tune in for our webinar next week, next Thursday at the same time.
Yes. I think we have invitation that already left, and we will send a reminder for the next webinar next Thursday.
Lovely.
Can students of A level and HSSC without math apply for foundation program of engineering and technology?
Yes, they can. So the foundation year is built especially for students who do not have or who have not had maths experience or are, maybe have spent too long away from maths. So if you haven't got math at A levels or higher secondary certificate, that's what HSSC means. You still have so as long as you've done it at the GCSE level, if which I assume everyone must have done maths and English at GCSE level, we do take students for foundation year. Yeah.
So if they don't do A levels, because in some country there is no A levels, they would need to have actually studied science or mathematics, correct, to join an engineering course.
Not for a foundation year. For a foundation year,
not for foundation, but for direct entry, for example.
For direct entry, yes. So one thing I would suggest is there is a UCAS entry calculator. So if you go to our university webpage, there would be a UCAS points, or how many points do you need to be eligible for a first year, or without foundation year. You can go to the UCAS degree calculator, and it would tell you what you could enter your degree there, and it would tell you how many points does that equate to, and they can see if they meet the requirements. So for first year entry, yes, we need one numeric subject. So that may be maths, that may be physics, that may be applied maths. So it could be any of those, but they need one numeric subject. If they haven't got that, then it's the foundation year that we offer.
The foundation year. Okay. I have a question specific for myself. For data intelligence student, for example, in postgraduate, they have what is the workload? So it is very detailed on the website, but in reality, how many hours do they have face-to-face? And how many hours they have to put in their own work towards the master degree?
Okay, so at every level, I'll give you a breakdown of both from undergrad to masters. So in undergrad, every module that we put for a semester, so a student will be doing 3 modules a semester, and they end up doing, so for every 20 credit module, you're expected about 200 hours of learning. So out of that 200 hours, you will get about 50 to 60 hours of contact, and the rest would be your own
Okay.
learning. Okay.
And can you tell a little bit more how they do study online, what they use to study online when they are on their own?
So when they're on their own, they will be so in that 200 hours, 60 hours will be contact. So the 140 hours doesn't mean that you'll be left on your own. You'll be given tasks like, okay, do this bit of reading that you might have to do, prepare for assessments. There will be small tasks here and there that you can do by yourself. You can, the labs are open. You can come do work and learn in that way as well. So that's the recommended design that we follow. And as we increase the level, the contact hours go down a little bit. So for first year, it might be 60 hours of contact. For level 5, it'll be 50 hours of contact. It's just to make them a bit more mature and independent learning and promote that as well. So I know those terms mean not a lot. It can be confusing. So in simple terms, when you're doing a master's, you're in 2 days. You're in 2 days a week, 2 days of contact, be it lab, lecture, or drop-in session, and the rest 3 days that you do work on your own, based on your
Okay, and do they need to bring their own equipment, like their own laptop, or is there a requirement for their
no.
computer?
So one floor of the Verona Homes building that we showed is labs and computer labs. So you can sit and use those computers, and any high spec software that we tend to use, we've got a virtual system where it all sits on. So anywhere you're sitting, even if you're sitting at home 100 miles away, if you just log into virtual desktop at canterbury.ac.uk, you will have access to the softwares. So all you need is a laptop with internet. So please, if you're joining us, do not spend a few £1,000s on an expensive
Or a
laptop.
brand new laptop?
Yeah,
Okay.
just any laptop would do.
Okay, we have a question regarding the academic requirement that we basically quickly overviewed. So A levels, or you will need to have one math subject at least. And please, for the requirement, refer to your regional manager, because every country has different entry requirements. So please refer to them what it is for your country. I do have another question, because engineering is absolutely a fantastic subject to study and to graduate from and to achieve a career afterwards. If, let's say, I'm an undergraduate student interested in electrical engineering, is it something that is offered by CCU, or what will be the courses program in that case?
We don't offer electrical electronics, but think about general engineering. So we do have an electrical lab, and students do a couple of modules on electrical electronics. We don't offer it as a specialization, but so let's say general engineering. General engineering has a little bit of electrical electronics, has a little bit of mechanical, has a little bit of control systems in there. So they get a selection of each. And then okay, this is something that I'll try and give a perspective on, but I'm helping my final year students apply for jobs. Okay, if you look at the jobs right now, there's a website called Grad Cracker. If you all want to look at it, they will say engineers required. Even if they say electrical engineers required, they will say, oh, we're happy with mechanical or control systems or systems engineering. So there are engineering courses, the mechanical one or the computing ones. They are, you learn these skills, you can apply it to any industry that you're going for.
Okay. Very good. Very good.
I had to say, sorry.
Yeah.
On your previous question, I just remembered about softwares and laptops. It's when you're doing an engineering degree, we've got a room especially open late, only for computing and engineering students, because that room has the software. So if you're living close to the university, you can spend time and use that rather than spending too much money on a laptop to try and access some software.
You mentioned in your presentation as well that engineering, the field in general, does
Yeah.
not have enough graduates every
Yeah.
year to
Yeah.
be in the workforce. Can you tell a little bit more about the opportunities for international students to find either a part-time job or a job after graduation in the engineering field specifically?
In the engineering field, if you, we've got students now. Okay, I will tell you the layout of the final year students. So they start the final year in September. Graduate roles for the following year start in that October. So a lot of them are going through opportunities right now. A couple of our students from chemical engineering last week had an interview with GSK. They didn't get the job because they couldn't start that day because they're still studying. So
Okay.
they're saying, okay, we'll put you on hold and maybe you start the day you graduate because they want engineers right now. So a lot of the students that we have, I feel once they get through the first stage, once you get shortlisted, they're able to do very well and get a job. And I would say all of the students from our cohort who wanted a job have got one, and the others have gone on to do gone on to higher education. And they, about we've got a stat saying about 85% of all our graduates are in industry within the first 15 months of graduation. But if you just take engineering, I would say that that's a lot lower. It wouldn't take 15 months to, you'll all have a job within the first 6 months if you do. If you present
Excellent
yourself well
news.
enough. Yes,
Yeah.
if you present yourself well, you have job. We get emails from local companies who might not put out, they don't have the finances to put out an expensive ad somewhere. They're like, oh, do you have a student? We need a couple of them. Yeah. And then now we're building relations in a way that we've got a student who graduated last year and is working at a company, and he messaged me yesterday, my boss wants another graduate. Can we come in? So, it's that relation
Absolutely. It's
we've
building
built.
up.
Yes. So
Excellent.
so
Excellent.
that's what I would say. It's not just about the degree, it's what you want to do about the degree. And if you do, I would say the bare minimum, you will have a job. It's that easy. But you have, we need you to learn and, progress and improve, and then you will have a job. But
Another question is regarding the MSc manufacturing.
yeah.
It is not forcibly maybe an engineering graduate that will go. Is it open to other people, for example, factory managers, or is it
Yes.
very specific to the science field?
It's not very fair. So some of our degrees, yes, we need, we have certain requirements to get in, but if you've got practical experience, we take that into consideration as well. So that would have to be, they would have to have the interview rather than just judging a student on paper. We might have to have an interview with them online to try and judge if they have the right skills that they would be able to cope. Because with a master's degree, you get a very short time to get up to speed, try and things. So if you have industry experience, yes, it does count towards your entry requirement.
And a final question from my side, because it is, question that I'm getting asked a lot. For a student that is doing a master degree, it is very compact at the end of the day. It's 1 year focusing on a very large subject. Would they have time to have a part-time job as well, or not really?
No, there is always time for a part-time job. And I'll tell you this, some of our students, I know if you're on an international visa, then it's a 20-hour limit. But we've had a few students who are mature students, and during COVID, they decided to retrain themselves as engineers. So they have done full-time job, full-time education. So they are able to do that. It takes a lot of effort, but the way our timetables are set, so we try to get them in. So undergrad would be in 3 days a week. The postgrad will be in 2 days a week. So it gives you 3 days to find 20 hours of work in and about those 5 days for the rest of the week. You can do very well. And if you have got good research ideas, you might want to work with the university, you speak to the academics and get an internship funded, and that way you're getting good pay while working. So it is adding to your CV, and you're getting paid, and you're still learning, and you're still studying. So options are available. They just need to, work for it and ask. A lot of the students don't tend to ask, and if they ask and build that relation, it's very easy.
Okay. Now I have a couple of questions for Richard.
Yes,
Richard,
please.
first, can you tell us a little bit about the tuition fee for international students?
Of course, Sybil. Yeah, thanks for the question. So our tuition fees, our total price is £15,500, but we offer a scholarship for our international students. So our international student scholarship is £1,500. So this reduces our tuition fees to £14,000.
Okay, and
Sybil, I could also mention the deposit.
Sure.
So we require a deposit of £5,000. And then there are a few different options about how you would pay the balance. You can pay the balance off in full, or you can pay in 2 installments. The first would be in September when you commenced your studies with us. And then the second installment would be in January.
And a second question about accommodation. How far is the Verona homes to the accommodation that Canterbury Christ Church University offers?
Oh, thanks, Sybil. That's a fantastic question, actually, because Canterbury is, it's a beautiful historic city, as Dr. Adil mentioned, but it's fairly small. You can walk across the city in about 25 minutes. We've got many different accommodation options for our students, and everything is within easy walking distance. So living in Canterbury, you don't really have to rely on a bus or a train. You can literally walk everywhere. So Verena Holmes, for example, would be 5-10 minutes walk from many of our accommodation options.
Okay, very good. Going through the questions again, if there's anything. No. Is there anything you would like to add, Dr. Adil? Give us a last word for why study engineering.
No, I just wanted to add what Richard was saying. Even though, the Canterbury campus might be a 10-minute walk, these student dorms are right next to the university library. The library is literally a minute or 2 walk, and it's across the wall. You cross the wall, you're right into city center. So,
and as far as I know, it's an award-winning library. It's a very complete library that Canterbury Christ Church have in the premises.
It's a nice place to work. It's got very nice views of the cathedral, so could be slightly distracting if you want to concentrate and study. But yes, Canterbury as a town is tiny. But,
Okay. Richard, a last word from you?
Yeah, just thank you so much again, Sybil, for hosting. Thanks, Dr. Adil, for speaking about engineering. Maybe the last thing that I could mention is that we are #1 in the UK for employability. So we're #1 in the UK for finding our graduates employment, something we're really, really proud of. And, employability really is embedded across the university and across our curricula, and really is in our DNA as a university now, because we're #1. So thanks, Sybil.
Thank you very much, Dr. Adil. Thank you very much, Richard. So for all the students, all you have to do is reach out to your agency, your regional manager, find out about the requirements, and please don't hesitate too long to put your application in, because we are getting closer to the next intake. Thank you very much all for your time. Thank you, Dr. Adil. Thank you, Richard.
Thank you. Thank you, everyone.
Bye.
Take care.
Bye-bye.